In this video, we're going to be solving a solution stoichiometry problem. So let's jump right into it. Let's suppose we have this question where it's asking how many grams of cobalt 2 phosphate will be precipitated when 150 milliliters of 0.25 molar sodium phosphate is mixed with 135 milliliters of 0.35 molar cobalt 2 chloride. Well, before you actually do anything, you have to be able to write down an balanced equation, and there are going to be times when you actually given a balanced equation, but in this question, I didn't give you the balanced equation so that we can practice writing in a balanced equation as we go here. So our reactants are going to be the sodium phosphate. So sodium is Na1 plus, and phosphate is PO4 3 minus, and so the formula for that is going to be Na3PO4. Okay, and then in addition to cobalt, 2 chloride is the other reactant we got. So in this particular case, cobalt has a 2 plus charge and chloride is going to be 1 minus charge. So when I put the formula together, it's going to be COCl2. All right, so now let me just go ahead and write down their equation. So when I have Na3PO4 sodium phosphate mixed together with cobalt 2 chloride, it's going to make so you want to make sure you do the inside, so you swap the ions basically. So in case of the reactants, I have the sodium combined with the phosphate. Now I'm going to have the sodium combined with the chloride, so that goes right there. So outside stays outside and inside stays inside. And I can see, I'll change the colors there maybe. I can see the sodium here is going to get combined with the chloride here. So when that does get combined, what the formula going to be? Well, it's going to be NaCl, because remember there is a 1 plus charge on the sodium and 1 minus charge on the chloride. So to balance out the charges, you just need one of each. Okay, then what about the second one? Let's say I have this phosphate right there. Okay, so this phosphate is PO4 3 minus, and cobalt is a CO2 plus. So when you put these together, what's going to be the formula? Well, I would need 3 of the cobalts to balance out the 2 phosphates there, because if I just go and write down on the side here, this 2 plus and 3 minus must equal to one another, and to make those equal to one another, I can have 3 of the cobalts, so that makes it a 6 plus charge, and I can have 2 of the phosphates, and that'll make a 6 minus charge there. And that's the only way you can balance out those charges. So the formula becomes CO3PO4 2, and that's going to be the solid. And the question literally tells you how much of the cobalt 2 phosphate will precipitate. So that means that's going to be the solid, and everything else is going to be in the aqueous form here. All right, so the cobalt 2 chloride is going to be aqueous, because remember, according to solubility rules, most of the chlorides dissolve in water. According to the solubility rules, the sodium phosphate is going to be aqueous, and so is the NaCl here. Okay, and then once you write down your products here, you want to make sure your reaction is balanced. Sometimes you don't have to do anything to balance the equation, but sometimes you do have to change some coefficients here and there. Now, if I start out with my biggest subscript in there, well, cobalt's got one of the biggest subscript here on the product side. It's got 3 cobalts. So to balance out the cobalts on the reactant side, I would have to put 3 in front of the cobalt 2 chloride. Okay, and then what else can be done? Well, I can also look at my phosphates on the product side. I have 2 phosphates on the product side because it's PO4 2. So that means I need to put 2 in front of sodium phosphate, and that takes care of the phosphates and the cobalts. Now, what happens to the sodiums and chlorines? All right, so on the reactant side, I got 6 sodiums here and 6 chlorines here, because remember, this coefficients gets multiplied with the subscripts there. Okay, so you have 6 of each. That means I can go ahead and put in 6 in front of the NaCl. All right, so the product that we really focused on is the cobalt 2 phosphate. All right, we have to figure out how much of cobalt 2 phosphate we're going to be making if we are given 150 milliliters. So we got 150 milliliters of sodium phosphate, and that's the molarity of that is 0.25 molar. And then for the cobalt 2 chloride, it's 135 milliliters, and the molarity is 0.35 molar. Okay, now just like in a typical stoichiometry equation, you may be given the masses and where you convert the masses to the moles and then figure out the moles of the products before you finding the masses of the product. We have to do exactly the same thing. However, our starting points are different. We're not given the masses, but we're given the molarities and the volume. And from the molarities and the volume, you first find the moles of that particular reactant, and then from the moles of the reactant you find the moles of the products, and then from the moles of the product you can figure out the masses. Well, and in this particular case, since we have two reactants, I don't know which one of them is going to be the limiting. Whoever or whichever makes the smallest amount of cobalt 2 phosphate is actually going to be your limiting reactant. All right, so we have to do calculations using both of those one by one. So let's start with sodium phosphate. So I have 150 milliliters of sodium phosphate. How much is that going to be in liters? Well, that's going to be 0.150 liters. And remember, this 0.25 molar is going to be the same as moles divided by liters. Okay, so first figure out the moles of sodium phosphate. From the moles, so you're given the molarity, all right, so we'll just write that down maybe for one of them. When you're given the molarity, find the moles of the reactant in this case, and then find the moles. From the moles of the reactant, so you go to the moles of the product, and then from there you can calculate the mass. Okay, all right, so let's try that. If I start out with 0.150 liters of sodium phosphate, and we're told we have, I want to put the moles of sodium phosphate on the top here, and then liters on the bottom, so I would have 0.25 moles and divided by 1 liters because that's the molarity of this sodium phosphate. And you can certainly use the definition of molarity if you want to calculate the moles of the sodium phosphate. I'm still using the definition, but I'm just writing them in the form of dimension analysis because you can see it easily. So once you have this written out, you can clearly see the liters will cancel out. Okay, so when you set these things correctly, everything will cancel out except what you're looking for. Okay, so the next step we have I want to convert, once you have the moles of sodium phosphate, I want to find the moles of cobalt 2 phosphate. So I'll write down here moles of cobalt 2 phosphate, and then I want to get rid of moles of sodium phosphate. Okay, so then this is where I'm going to be using the stoichiometry relation, so that's why it was important to balance the equation. So I have 2 in front of sodium phosphate, I got 1 in front of cobalt phosphate, so this is where we're going to have the stoichiometry relations written out. Okay, so when you do so, you can see how your sodium phosphate's mole cancels out, okay? And then in the next step, I can go ahead and find the masses of this cobalt phosphate because that's what we're really trying to figure out. Now, if you have the moles of something, how do you find the mass? Well, you use the molar mass or the atomic mass as equality. So I'm trying to find the grams. I'll put grams of cobalt 2 phosphate on the top, and then I want to put the moles of cobalt 2 phosphate on the bottom. Okay, so that way the moles cancels out and then you're left out with only grams. So what number goes here? Well, 1 goes with the moles, and the number that's the molar mass is going to be for cobalt 2 phosphate is going to be going with the grams here, and the molar mass for cobalt 3 phosphate, make sure you add up 3 cobalts, 2 phosphate, and 8 oxygens, and that comes out to be 366.7 grams. Okay, so when you do so, you can clearly see everything cancels out except the grams of cobalt 2 phosphate. Okay, so I can go ahead and do this math and see what that comes out to be. So I got 0.15 times 0.25 times 366.7 and divide that by 2. And that comes out to be 6.88 grams. Okay, so right now, I don't know if we're really making that much because we haven't really checked the other reactant. So we're going to do the same thing with the other reactant now. So we have 135 milliliters of cobalt chloride, and that's going to be 0.135 liters. Okay, so I'm going to write that down here. So if I'm starting with 0.135 liters, and I know the molarity of cobalt 2 chloride, that's 0.35. So I write down moles of CoCl2 divided by liters, and that's going to be 0.35. And one goes with the liters, so you can clearly see how the liters cancels out. So it's the same setup, but you're just starting with a different material now. And then you want to go ahead and convert the moles of cobalt chloride to the moles of cobalt 2 phosphate. So I want to calculate the moles of cobalt 2 phosphate, and I want to get rid of moles of cobalt chloride. And then you can see the stoichiometry relation back here. I have 3 in front of cobalt chloride, and I got 1 in front of cobalt 2 phosphate. So I'm going to have 3 here and 1 here. Okay, so these steps are the same what we have done in the previous with the previous reactant, but just a different reactant now. Now we're doing with the cobalt chloride. So your moles of cobalt chloride cancels out, and then finally I want to convert that to the mass of cobalt 2 phosphate. So I want to go ahead and put the grams of cobalt 2 phosphate on the top, and I want to put moles of cobalt 2 phosphate on the bottom. So this last equality actually stays the same. And then 1 goes with the moles, and you have 366.7 that goes with the grams of cobalt phosphate. So then at the end of the day, the moles of cobalt 2 phosphate also cancels out, and that leaves you with only grams of cobalt 2 phosphate. Okay, so then you can go ahead and do this math here. We got 0.135 times 0.35 times 366.7 and divide that by 3. And that comes out to be 5.77 grams. Okay, so in case of sodium phosphate, we actually made 6.88 grams of cobalt 2 phosphate. And in case of cobalt 2 chloride, we made 5.77 grams of cobalt 2 phosphate. Okay, so what's your actual yield going to be, or how much of the product you're going to be making here? The final answer is going to be 5.77 grams here. That's going to be made here, and your limiting reactant would be the cobalt 2 chloride, because once you have made 5.77, the cobalt 2 chloride runs out, and that's going to be your limiting reactant. And then your other guy, the sodium phosphate, becomes your excess reactant. So hopefully this video was helpful. If you have any questions, leave any comments below.